All right, welcome to Computer Science 305. This is part 3 of the third Java lecture, and we're continuing on learning about exception handling. And this last part, we're going to be talking about the finally. So, try has one extra part. So, if we've been looking at our test, right, we had our try, our catch, and we had a whole bunch of different catches and everything like that. Well, there's one extra part, right? So, oftentimes, you'll have some extra business to occur regardless of whether or not the try occurred or the catch occurs. We may have an extra piece that we need to actually of code that we need to execute in either case, which is where we use a finally block to handle that. So regardless of what happens, even if a catch occurred, we still, like, for example, if we opened a file and we or stream to the on the network, right? And we were doing things like that with that inside of our try block, and in the middle of that, an exception occurred. Well, we're going to need to clean up what we were doing and close that stream down. And we can do that in the catch, or we can just do that in the finally block, right? So the catch will handle the exception handling part, like we may need to log some things, something else happened. And then in the finally, we'll close the stream down and do what else, and clean up anything else that we need to clean up. And so, regardless of what happens, the finally block is always executed. So finally, for example, we can open up a file. We can then run a try. We work with the file, and then at the end we say finally file.close. So regardless of, and the beautiful thing here is you don't actually have to have a catch at all. You can just have a finally. So bear that in mind. Catches are optional, finally is optional, but note that the finally code will always execute. So an example of this would be what we see here, right? Where we simply have this block. We're going to say system.out.print. And then what we'll say is if true, throw a new exception. Right, so this will always throw the exception. We say system.out print 3, which will never execute. Then we're going to catch the exception. And we'll print out 4. And then we'll call the finally, right, where we print out 5, and then 6 at the end. Okay, so we go ahead and execute that, right, and we get 1, 2, 4, 5, 6, as expected, right? Because 3 will never happen because we throw the exception always because of the true. So, pretty simple. Finally, just is saying this is going to happen regardless of whether or not the try executed completely with no exception, or if an exception was thrown and was caught, or if the exception was thrown and wasn't caught. Doesn't matter. The finally will always execute. All right, and then at the very end. So, we covered a lot in Java. One of the things we didn't capture was, there's a whole bunch of, there's like 4 primitive types we never talked about. We never talked about the enum type constructor for enumerations. We didn't handle other statements like do, for, break, continue, switch, and assert. There are some refinements that we didn't really talk about, which include inner classes. So these are classes defined within classes, or in blocks, or in expressions. There's lots of ways to do that. We didn't talk about generics. We didn't talk about functional programming in Java. We did not talk about some of the new stuff that came up in Java 9, which is the module system. Nor did we talk about the new stuff in Java 10, which is the var. We also didn't talk about a variation of the try, which is called try with resources. We did not talk about the enhanced for statement. We didn't talk about a lot of things. Java is a vastly expansive language that has been evolving for the past, just about 20 years now. No, sorry, the last, almost 25 years, actually. So there's a lot of stuff that's been going on in it. It's very robust. I would suggest, before you dismiss this as a language that you might want to use because of a lot of boilerplate overhead and things like that, which is handled by tools and other libraries, you might want to take a look at it for future projects or one of its derivatives like Scala, Groovy, Clojure, because these are powerful languages that all interact. And you have to understand that Java has an extremely large library of open source projects and code that are associated with it that make it very useful. Furthermore, it has a very good build system, or several different build systems and dependency management systems that, in my opinion, far exceed pretty much any other language in existence right now, including Python, Ruby, and .NET languages. Furthermore, it has all the same capabilities that languages like Python have for example, machine learning and data science. It has all the libraries that you could ever want for that and more. Furthermore, a significant number of the libraries that exist for doing a lot of those things are written in Java first before they're ported to Python, or if they were written in Python, have been similar ones have been ported for Java as well. For example, TensorFlow is available for Java. Everything's available for Java. Everyone uses it at some point in time. And furthermore, when you go to shift from a language like Python, which is dynamically typed, and you need security, maintainability, and capabilities to build robust, large systems, you're going to eventually have to shift to something similar to Java that is statically typed and easier to understand and is what we'll call more robust. So that's my last piece on Java. The other things we didn't talk about before I get into this, packages and how to understand these things. The different types of actually utilizing the different types of directory access or default access. And then concurrency, although I think I will talk about concurrency in Java as the last part of this class. So we will talk about it a little bit more. And then, of course, the rest of the API, which includes GUI, 2D, 3D graphics, math, pattern matching with regular expressions, file I/O, network I/O, XML, encryption, security, remote method invocation, databases, and a whole bunch of other stuff that I got done mentioning about 30 seconds ago. So enjoy that. Java's quite a vast language. It's very powerful. Don't be fooled. Anyway, have a great day. I'll see you all in class.